Howdy! This is your friendly neighborhood physics teacher here. I'm here to help you review for your force review. I apologize for my voice. Hopefully you understand me. My howdy was very squeaky. But if hopefully y'all can understand me. I'll do my best. I'll speak lower if I have to. So question number 1. What happens when all the forces on an object are balanced? When you see the word balanced, there's a couple of things that should pop into your head. It should pop into your head that the net force equals 0, and that acceleration equals 0. So since net force is 0, your acceleration is 0. If your acceleration is 0, two things can happen. It can either be A, not moving. Another way you could say that is at rest. Or it can be moving at constant velocity. It can be moving at constant velocity. So not moving, or it's at rest, or it's moving at constant velocity. So those are two things that can be happening when the forces are balanced. So what happens when the forces aren't balanced? That means you have some type of net force. Net force equals some number. Acceleration equals some number. So therefore the object is accelerating. So it is accelerating. So what are the forces we label in a free body diagram? We do our force of gravity or weight. You can put it either way. We do our force of normal. We do our force of friction. And we do a force applied. So those are the four main formulas that can happen. Force of gravity or weight, force of normal, force of friction, force applied. It says draw a free body diagram of a car moving at constant speed down a highway. So we have our little car here. My little Subaru, as my students call it. So what forces are acting on this vehicle? Well, we have force of gravity. If you say force of gravity, that you're going to be 100% correct because force of gravity affects everything. Then we have force of normal with the ground up on the car. Then we have some type of force applied. So it's like you pushing your accelerator, and then we have a force of friction. Since it's at constant velocity, constant speed, remember what we're supposed to see when we see constant speed? Our acceleration equals 0. So therefore, our net force equals 0. So the forces are balanced. The forces are balanced. And the main thing we're talking about, because it's only moving in the x direction, so the forces are balanced in the x direction. They technically are balanced in the y direction also, but it's just because it's not moving in the y direction. So balanced in the x direction and it's moving. They're balanced in the y direction and it's not moving. It's not moving. Okay, so it says draw a sled going down the hill. What forces are acting on it? So we have a hill, we have our sled. So what forces are acting on it? Yep, force of gravity. Force of gravity goes straight down. We have a force of normal. Remember, in this case, force of normal goes with the surface. And since the box is going down the hill, or the sled's going down so you do have a force of friction going up the hill. Since it's going, you have a force of friction going up the hill. because the movement of the sled is going down. So what are Newton's three laws? The first law is the law of inertia. So it's law of inertia. I think I misspelled that. Basically, an object motion stays in motion, an object rest stays at rest. So whatever the object's doing, it wants to continue doing that. Matter is lazy. Newton's second law is just your force equals mass times acceleration equation and how they interact. And Newton's third law is for every action, there's an equal and opposite reaction. So it's just an action-reaction. So action-reaction. So what is the action-reaction pair or pair forces of these actions? So if the book is pushing on the table, so let's draw a little table. We have a book. So we're saying that the book is pushing on the table. So that's like force of gravity. So what's keeping that book from going through that table? It's a force of normal. So if the book is pushing on the table is pushing back on the book. So it's the force of gravity of the book pushing down and the table pushing up. That's an action-reaction pair. So if you were leaning on the wall, if you were pushing on the wall, so if you're pushing on the wall, so you have like some type of force applied because you're pushing on the wall. What's the opposite of that would be a force, a normal of the wall. So you're pushing on the wall's pushing back on you. If we have a ball on the string, so the string is holding up the ball. So we have a force of tension here. Force of tension. So you have the string holding up the ball. But in theory, we also have the ball pulling down on the string. So if the string is holding up the ball's pulling down on the string. That's your action-reaction pair. So when an object is being pulled at a constant speed of a force of 30 newtons, what is the frictional force? So let's draw a free body diagram so we can see what's going on. So we have it's being pulled, so that's our force applied. And it's wanting to know what our frictional force is. So if our force applied is 30 newtons, key thing there, we have some key words. We have constant speed. Remember, at constant speed means net force is 0, acceleration is 0, so therefore the forces are balanced. So for the forces to be balanced, our force of friction has to equal 30 newtons as well. So what's the purpose of the force of friction? What is the force of friction? How does that affect the motion? It does two things. It can either A, slow it down, or it can just prevent it from moving altogether. So it prevents it from moving altogether. So either slow it down or prevents movement altogether. So number 10, or actually I need a lot more space than that. Number 10. Number 10 is actually missing a few things, and I'll send this out in the remind. So you need the mass of the block. So the mass of the block should be 2 kilograms, and you also need the mu. The mu will be 0.2. So those are 2 missing items from this problem. I will definitely put that in through the remind so you get that information. So this is where the steps come into play. So step one, remember step one is draw a free body diagram. So step one is to draw a free body diagram. So we always have a force of gravity go straight down. We have force of normal going straight up because our surface is straight. And we have a force applied. Then we also have a force of friction. Since it's moving in this direction, it's moving in that direction, so the force of friction always goes opposite of the motion. So step two, so we're going to solve for force of gravity. So force of gravity, the equation for force of gravity is your mass times your acceleration due to gravity. So the mass is 2, your acceleration is negative 9.8. So you do 2 times negative 9.8. And you get negative 19.6, so 19.6 newtons as your force of gravity. Now remember, that negative just means it's going down. So that arrow, so it just means it's going down. So step 3, step 3 is you're going to break it into its x and y components. So you have to find your force applied in the x, and you need to find your force applied in the y. That just should be force applied. Force of pull, force applied, yeah. Force applied in the x, force applied in the y. So we break this up into its x and y components. So we have, so that'd be force applied in the x, because that's in the x direction. Then we have force applied in the y. That makes a 90-degree triangle. So this is our hypotenuse. If our angle is here, this becomes our opposite. This becomes our adjacent. So if we're looking for our f of x, it's adjacent, so we're going to end up using our cosine. Cosine. So cosine theta is adjacent over hypotenuse. So again, our adjacent is force applied in the x. Our hypotenuse is just our force applied. So we can plug in what we have. We have our angle. Our angle is 35. We don't have our force applied in the x, but we have our force applied. Our force applied is just 30 newtons. So how do we get a force applied in the x by itself? You're being divided. The opposite of divide is multiply. What you do to one side, you have to do to the other. So you get force applied in the x to be 30 cosine of 35. You plug that into your calculator. Make sure your calculator is in degrees. So you do 30 cosine of 35. And that gives you 24.57 newtons. Next, you do your force applied in the y. So y is your opposite. So you're going to use sine theta equals opposite over hypotenuse. So your opposite is your force applied in the y. Your hypotenuse is force applied. You can plug in what you have. Your angle is 35. you're looking for your force applied in the y. Your force applied is 30. To get force applied in the y by itself, it's being divided, so the opposite of divide is multiply. What you do to one side, you have to do to the other. So you get your force applied in the y of 30 sine of 35. You plug that in. Again, it should still be, but make sure you're in degrees. So 30 sine of 35, that gives you 17.21. Step 5 is to find your force a normal. Now remember, to find your force a normal, everything going up has to equal everything going down. So all the forces going up have to equal all the forces going down. So what forces do we have going up? So we have force of normal. So we know that's going up. So let's see here. Oh, look, force applied in the y is also going up. So plus our force applied in the y. Those are the only ones going directly up. And then we equals all the ones going down. So the only force we have going down is force of gravity. So all the forces going up have to equal all the forces going down. We're looking for our force of normal, so we want force of normal by itself. The opposite of adding is subtracting. What you do to one side, you have to do the other. So you get your force of normal equals your force of gravity minus your force applied in the y. Your force of gravity was 19.6 minus your force applied in the y. Where'd it go? Oh, it's down here. Force applied in the y is 17.21. Now remember, we do have a negative here, but that negative is just telling us it's going down. We've already taken that into consideration when we set them equal to each other. So now we just do 19.6 minus 17.21, and you get and you get 2.39 newtons. So that is your force of normal. Step 6. Step 6 is asking for your force of friction. So your force of friction is just your friction equation, which is your mu times your normal force. Your mu in this case is 0.2. Your force of normal, we just figured out, just 2.39. So you just do 2.39 times 0.2. And your force of friction ends up equaling 0.48 newtons. Ends up equaling 0.48 newtons. So now, step 7 is to figure out your net force, specifically in the x direction. We already figured out our net force of the y. So that's our net force of the y we just figured out. But our net force in the x, we need to know all the forces that are moving in the x direction. So what forces are moving in the x direction? Yep, force of friction and force applied in the x. So our net force, so we have our force applied in the x, and we have our force of friction. They're going in opposite directions, right? So our force of friction has to be negative because it's moving in the negative direction. our force applied in the x was 24.57, and then that'll be subtract 0.48. Our mass was 2 times acceleration. So you go ahead and take the 24.57 minus our 0.48. That gives us a 24.41 equals 2 times our acceleration. It's being multiplied. The opposite multiplies divide. What you do to one side, you have to do the other. So we're going to divide that by 2. And we get we get 12.05 meters per second squared as our acceleration. So there we go. So I kind of did step 7 and step 8 kind of together, but that is for a pulley. You pulled at an angle. So if a 20,000 kilogram car is accelerating at 2 meters per second squared, what is the force acting on the car? So this is just a straight F equals ma. So your mass, 1, 2, 3, 4, 1, 2, 3, 4, times your acceleration. And that'll just equal 4, 1, 2, 3, 4 newtons. So how do you calculate force of gravity? That is just your force of gravity equals mass times acceleration due to gravity. How do you calculate weight? Well, guess what? It's the same thing, because weight and force of gravity are the same. So how does weight and mass differ? So weight is a force. Mass deals with matter. So how much matter you are made up of. So I did that joke in class saying it should be called mass watchers instead of weight watchers. Because to physically lose weight, you have to lose mass, because the acceleration on Earth isn't changing. So you have to lose matter, lose mass. Does acceleration due to gravity affect the amount of mass on this object or on a object? The answer is no. So if we take a ball and it's on Earth versus on the moon versus on Jupiter versus on Saturn versus on Venus, all that, the mass does not change. Mass does not change. So what is the normal force acting on a 20 kilogram box that is being pulled forward with 10 newtons on a flat surface? So flat surface being pulled at 10 newtons. So when you know what the normal force is. So don't forget, we do have force of gravity here, and I'm sure we have some force of friction. So the surface is flat. It's not moving in the y direction. So you just have to worry about your force of gravity and your force of normal. So it's not moving in the y direction. So therefore, net force equals 0. So they're balanced. So force of gravity will equal your force of normal. So force of gravity is just your mass times acceleration due to gravity. The mass was 20. Acceleration due to gravity is just 9.8. So you get that the force of normal equals 196 newtons. So it's asking what is the normal force if it's being pulled at an angle. So it's the same thing. But object's being pulled at an angle now. So it's being pulled at 10 newtons. We still have force of gravity affecting it downward. We still have force of normal going up. But in this case, now we have a force applied in the x, and we also have a force applied in the y. So we have to take that into consideration. And the angle is now 25. So that's our hypotenuse. This would be our opposite. This would be our adjacent. So if we're doing our force applied in the y, so force applied in the y would end up using sine. So sine theta equals opposite over hypotenuse. Sine theta, our opposite is force applied in the y. Our hypotenuse is force applied. So sine of 25 equals, we're looking for a force applied in the y. Force applied is 10. It's being divided. The opposite of divide is multiplied. When you do one side, you have to do the other. So you just end up doing 10 sine of 25. So you get a 4.23 newtons for your force applied in the y. And again, if you're looking for your force of normal, remember, if you're looking for your force of normal, everything going up has to equal everything going down. Well, now force of normal is going up and force applied in the y is going up. And that has to equal everything going down, so that's your force of gravity. So to find force of normal, you subtract your force applied in the y. So your force of normal equals force of gravity minus your force applied in the y. Your force of gravity is just your mass times acceleration due to gravity. So your mass of the block was 20. Acceleration is 9.8. So your force of gravity is still 196. That does not change. So you do 196 minus 4.23. And you get 191.7 newtons for your force of normal. So your force of normal equals 191.7 newtons because you have that little bit of force helping that force of normal. On number 15, you don't have any. The force just goes going straight horizontally. Now that you're pulling it up a little bit, you're kind of relieving that force of normal. You're relieving that force of normal. So 17 is asking for your relationship. Remember, your mass is a direct relationship. Your distance is an inverse relationship. So the answer is B. Because if you look at your equation, G and 1 and 2 divided by r squared, if you look at that equation, you just look at your mass, force of gravity and mass, they're both on top. So that's a direct relationship. If you look at your distance, it's on bottom. So it's an inverse. And then you cannot forget about that squared. So it's actually an inverse squared relationship. If the mass of the moon is doubled and the mass of the earth remains the same, what happens to the gravitational force then? So if this doubles, that means your force doubles because it's a direct relationship. If the mass of the moon and the earth remain the same, but the distance is cut in half, what happens to the gravitational force? So you have to take that square into consideration. So you have to do your square, or your 1/2 squared. So you get 1/4. So you get 1/4. But remember, that's inverse. So the inverse of 1/4, so that's 1/4. So that gives you 1/4. But the inverse of 1/4 is 4. Because you flip it. So inverse just means flip. So your force ends up quadrupling. So it does whatever opposite your distance. So if your distance decreases, that means your force is going to end up increasing. So if your distance decreases, that means your force is going to end up increasing. Compare the magnitude of the force that the Earth exerts on the moon to the force of the moon exerts on the force. It's actually the same. That's why we don't have to solve for different forces. It's still the same, because if you multiply 2 times 1 versus 1 times 2, you're going to get the same answer. So it's the same. So finding the missing forces of each object. So for A and B, it's part of this first little box here, and it says the net force is 0. So that means balanced. So if 50 is going to the right, that means 50 is going to the left. If 200 is going down, that means 200 is going up, because they are balanced. Net force equals 0. Acceleration equals 0. So for C, so net force says it's going 90 newtons up. So that means C has got to be bigger than the 200. Because if you subtract them, so you have to think about what subtracts to get 900. You can't just add them together. So you end up getting 1100 newtons going up, because the net force has to be, so if you know your net force, equals, let's just call it force of gravity, minus force of the air, or whatever. So to get that, so if your net force is 900, your force of gravity is 200, that means your force of air has to be, that should be flipped negative-wise, okay. That means you have to solve for what your force of air is, and you end up getting 1100. So for the next one, D. So it says your net force is 60 to the left. So this side has got to be bigger. So this side's bigger. So what would you have to subtract so you can get 60? Well, 20. And then it says it's only moving to the left, so it's not moving up and down. So that means our E has to be balanced. So they have to be going 30. So I'm going to skip F right now. We're going to do G. So it says it's moving 30 to the right. So again, so this one has to be bigger. So what does this have to be? So you end up going 30 to the right. G has to be 50. Very good. Because, again, if you do your net force equals your force applied minus your force of friction, your net force is 30. You don't know what your force applied is, but you know your force of friction is 20. So what it has to be to get there 30? 50. So actually, your F and your H just equal each other. You can make that any number because it's not moving up and down. So they can both be 10, they can both be 5. It doesn't matter as long as they equal each other. So number 2, or not number 2, this should be, the numbers got off when I copied and pasted. So this should be number 22. So number 22. And all my numbers got off. Cool. So I believe, trying to pull it up so I can see what it is real quick. Since it got taken off of my video. So we have 10 going up. We have 5 going down. We have 13 going to the left. We have 15 going to the right. So you have to only deal, force in the Y only deals with force in the Y. Force in the X only deals with force in the X. So if you're doing the net force in the Y direction, we end up doing 10 plus 5, but you have to take into consideration, so it'd be negative 5. So 10 plus negative 5 gives you 5. And then the net force in the X direction, so you have 13 plus 15. 13 is a big negative because it's going to the left. and that gives you 2. So always draw, if you're going to draw your triangle, draw your x-axis first. It kind of makes things a little bit easier. So that's 2. That's 5. And you're looking for your net force. That becomes a right triangle, and your angle is always where there's no arrowheads. So you're just going to use your a squared plus b squared equals c squared. It does not matter which one you make a squared. It does not matter which one you make b squared. So you end up getting 29 equals c squared. To get rid of that squared, you have to square root. And the square root of 29 is 5.38. So that becomes your hypotenuse. So this is your hypotenuse. If this is your angle, this is your opposite, this is your adjacent. You could use any sine, cosine, or tangent, whatever you feel like. I'm going to use sine. Theta equals opposite over hypotenuse. So I don't know what my angle is, but my opposite is 5. My hypotenuse is 5.38. To get theta by itself, you have to do the inverse sine of 5 over 5.38. You can just plug that into the calculator. Make sure you hit second sine. Then you just do 5 divided by 5.38 your calculator. Make sure you're in degrees. It'll give you an angle of 68.34 degrees. So there's your angle. So there's your magnitude. That's your net force or resultant force. There's your direction. If we're looking at quadrants, we're going to be in quadrant 1. So there we go. So last question. Last but definitely not least. We're going to go back to our steps. So step 1, draw a free body diagram. You know there's always force of gravity. It's on a surface, so there's force of normal. Force of normal goes with the surface. Since the surface is tilted, force of normal is tilted. And you're going to have a force of friction. Force of friction is going up the ramp. The force of friction is going up the ramp. Why is force of friction going up the ramp? Because you have your object is moving down the ramp. It's sliding downwards. So your force of friction always goes opposite of the motion. So your force of friction is going up the ramp. Now that we have our free body diagram, let's figure out our force of gravity. Force of gravity is mass times acceleration due to gravity. The mass of this block is 10. Our acceleration due to gravity is just 9.8. You plug that into your handy-dandy calculator, and you get 980 newtons. It is technically negative because it is going down, but we have an arrow showing that, so we don't have to worry about writing the negative down. So that's our force of gravity. Now we have to assess how we want to change our frame of reference. Makes our life a whole lot easier if we change x to go with the surface of the plane, and we change y to go up and down with the surface of the plane. So basically you're just tilting your head, you're tilting your paper, anything like that. If you want to rewrite it, you can. So basically you would have force of normal going straight up now, force of friction going to the right. The only weird one now is you have your force of gravity going at an angle. So that's just, all I did is I tilted the paper. I just changed our frame of reference. So now we can break our force of gravity into its x and y components. So you have force of gravity in the y, and you have force of gravity in the x. Do the same thing over here. Force of gravity in the y, and force of gravity in the x. That does make a right triangle. And your angle is up at the top because that's where we started. Remember, angle always goes where there's 2 ends, no arrowheads. Angle always goes where there's 2 ends, no arrowheads. And now we know our force of gravity, so that becomes our hypotenuse. Since that's our angles at the top, force of gravity in the x becomes our opposite. Force of gravity in the y becomes our adjacent. So now we can find our f of x, or f of gx and f of gy. Let's do f of gy. That's adjacent, so we're going to use our cosine. That's adjacent over hypotenuse. Our adjacent is our force of gravity in the y. Our hypotenuse is force of gravity. We know everything but our force of gravity in the y, so our angle is 30. We're looking for our force of gravity in the y. Our force of gravity is 980. To get force of gravity in the y by itself, you multiply both sides. And you get your force of gravity in the y to equal 490. And you just do the same thing with the force of gravity in the x. But in this case, we're going to use sine because it's our opposite. Our opposite is our force of gravity in the x. Our hypotenuse is force of gravity. We can plug in what we have. Our angle is 30. We're looking for our force of gravity in the x. Our force of gravity is 980. We want force of gravity in the x by itself, so we multiply since it's being divided. What we do to one side, we have to do the other. So we get force of gravity in the x equaling 980 times sine of 30. You plug that into your calculator, and that's what I get for pre-doing things, because that equals 490. I did that early in my calculator, and I wrote it down the wrong spot. So that equals 490. Come on, pen. There we go, 490. And actually, if you the sine would equal 848.7 newtons. There we go. So that's our force of gravity in the x. That's our force of gravity in the y. So next step would be to find our force of normal. So force of normal is all the forces going up have to equal all the forces going down. If you look at our free body diagram, we only have one force going up, force of normal. We only have one force going down, force of gravity in the y. Hot dog, we're done. Those equal each other. So force of normal just equals 848.7 newtons. The next thing is we need to figure out what is causing it to move. So what is actually making it cause going down the ramp? So you can actually call that as your force applied in the x. So what's making it cause going down the ramp is actually just your force of gravity in the x. So what's making it move is just your force of gravity in the x. The next, we have to find our force of friction. So force of friction equals mu times your normal force. Our mu is given to us. Our mu is 0.4. Our normal force is 848.7. You multiply those together, and you get 339.5 newtons. There we go. So the next step is to find your net force. So remember, your net force is all the forces that are affecting its motion. All the forces that are affecting its motion. So it's going down the ramp. So we already said the force that's making it go down the ramp is our force of gravity. Or you can call it our force applied in the x. And what's slowing it down would be our force of friction. That's going in the opposite direction, so you just subtract. So our net force would be 490 minus 339.5. So that is our net force. You subtract those, and you get 150.5 newtons. Now you can solve for your acceleration. Your net force equals mass times acceleration. Our net force is 150.5. Our mass of the block, I believe it's 10. Yep, it's been a minute. 10, and we're looking for acceleration. You get acceleration by itself. It's being multiplied. The opposite multiplies divide. What you do to one side, you have to do the other. And you get 15.05 meters per second squared, and that is your acceleration. Hopefully that helped. I know it's a lot. Don't forget I have helpful links. There's other videos, and you have the Kahoot. So if you have any questions, just let Ms. Verona or Ms. Heath know. Have a wonderful day. Bye.